Welcome back. Let's talk about something more interesting today. Hope you guys remember this diagram from the previous video, and you already know that this is the whole architecture of 8085. So today let's talk about the flag registers. So this is the structure of flag registers in 8085. In 8085 there is a 8-bit flag register. That means you can store 8 individual bits for your purpose in the flag registers, and this is a special purpose register, that is the programmer has no access to the flag registers, but you can obviously with some proper command see the status of the register. So let's see, the first of them is a sign flag. To understand the sign flag we have to consider an ALU operation. Let's say in A register there is a value D3 hex and in B register there is a value 2D hex. Okay, so you have written an instruction as add B. So you already know that add B means you have to add the contents of B register and A register together and store the result in A register itself. So while executing this command, the value of A register gets changed to 00 hex. Okay, so a simple binary addition you can do by yourself and see that this is exactly what it is coming. Okay, so what sign flag does is it copies the most significant bit of the result and copies it within itself. Okay, nothing else. So whether the result here it was 1 or 0, it had to copy that bit here. Next is 0 flag. So 0 flag gets 1 whenever the result is 0. So as you can see that the result is 00 hex in this case, so obviously 0 flag is going to be 1. Next is auxiliary carry flag. To understand this flag we have to do this addition step by step. So this is your lower nibble, this is your higher nibble of the first operand, and this is your lower nibble and this is your higher nibble for the second operand. After adding the lower nibbles, you can see this is the result that is coming and there is a carry from the lower nibble to higher nibble. So auxiliary carry flag stores this information that whether there was a carry from lower nibble to higher nibble or not. Okay, so as here is a carry from the lower nibble to higher nibble, auxiliary carry flag is going to be 1 in this case. If there was no carry, then it would be 0. Next, parity flag. Parity flag means this flag gives you the status of the result in such a way that whether there are even number of individual bits in the result or not. Individual bit means obviously zeros or ones. So as you can see that in this case, in this result there are 8 number of zeros. Okay, so 8 is obviously an even number, so parity flag is going to be 1 in this case. That means you know that result is going to be of 8 bit always. So if there are even number of zeros, that means it should contain even number of ones too. It is obvious, right? So the last flag is carry flag. To understand carry flag we have to carry out the whole operation. So after we carry out this whole addition operation, we can see the result is coming as 00 hex as you have seen earlier, and here is the carry. That means this carry is going to be stored in the carry flag itself. Okay, I hope this much is clear. So let's wrap up this video. The takeaways from this video are each flag is an individual flip-flop and so it can store 1 bit. So this sign flag, 0 flag, auxiliary carry flag, so all of these flags are individual flip-flops. That means this is a flip-flop, this is another flip-flop, this is another flip-flop, but this flip-flop, these 3 flags do not give you any information about the status of the result, so we have written them as crosses. Okay, sign flag is not reliable to check the result of the unsigned numbers. That means, as you have seen already, that a sign flag only copies the most significant bit of the result. So if the result is an unsigned number, that means sign flag cannot give you the sign of the number. Okay, so it will carry 0 if the MSB of the result is 0, and it will carry 1 if the MSB of the result is 1. So for signed number, that bit gives you the status of the result, that is the sign of the result, but in case of unsigned numbers, that is not the case. Parity flag is used to check the ambiguity of the sent and received data. That means, suppose I am sending you some data from my desktop to your desktop. Okay, so after checking that the sent data and the received data has the same parity, that means it had same number of ones and same number of zeros, it can be assumed that the primary checking is done and the sent data has been received unalteredly. Carry flag and zero flags are the most used flags in 8085 programming. We will see how to use them in the later video. So this is it for now, guys. Hope you have enjoyed the video. See you in the next one. Bye.